Okay, here is the fourth example problem associated with today's lecture. Actually, the lecture is running long, so I didn't go over this problem, and so we'll go over it. We'll do it now. It's actually kind of a good problem. So once again, this is a counter problem. I can tell it looks like a counter, but it has some weird stuff going on. And the issue is the weird stuff that's going on is it stays at 0 for 3 states. So it's a normal up counter. Obviously, it's counting up, incrementing, except when it hits 0 and it stays there for um, three three clock cycles. Okay, so the issue is, as with everything, let's draw a black box diagram for this. And it's a circuit. It has a 4-bit output. Certainly has a clock on this thing. Any control on this? Nope. I don't. I think that's it. No fancy outputs on this. So there's the top level black box diagram. Okay, so the issue is on this thing. I'm gonna do this twice and show you that one solution is wrong. Okay, so I'm gonna maybe make this. I think I'll just add another page on this when I get there. Okay, so here we go. This has a counter, so the heart of this thing is a counter, and so I have a counter in there. The maximum number is not 19. This should be a 10. I don't know. I think the sun got in my eyes or something. So it's another 4-bit counter. There's my count value. It's certainly going to have a clock. It looks like an up counter, but I don't want to mess with the up yet, because I got something weird going on there, and so I'm not gonna think about it right now. And so RCO, I don't feel like I need an RCO on this problem. If I need one, I'll add it later. But I do need some type of control here, so I'm gonna come over here because I know I need some space down there for a state diagram, and put FSM. And so what's going to happen on this thing is I need a God, I need an RCO on it. Okay, so I need to control that up, and it does in fact need an RCO. So RCO is going to be an input on the state machine, and I need a clock. Okay, and I think I'm gonna erase that. I like not cluttering the diagrams up here with the clock. Okay, up, RCO. I could have connected these, but I just decided not to. I think that's it. So the issue is that what I'm thinking here is when it hits 15, I need to know that because I need to do something different after 15, which is those 3 zeros over here. Okay, so the idea here is it can hit 15, and I'm not gonna do anything for a while. Essentially, I need to output 3 zeros, right? Okay, so that means I have no real clever way to do it. I'm just going to throw 3 states down there and leave it there. At least that's what I think I'm going to do. Okay, so I'm gonna do that and just start writing on this thing. And this is count state. I don't like that. I can do better than that. This is counting. This is counting up, and I'm going to keep counting up so long as there's no RCO. Okay, and so that means, check it out. I need to say I'm counting up, and this is the this is a more output, which is output of the state machine, which is the control input of the counter. It allows it to count up. So when it hits 15, it is going to kick out the RCO, and that means I'm going to I'll say 0_1 for lack of a better word. I don't like that either. We could do better. How about z_1? Okay, in that state, what I need to do is not count for 3 states, seemingly. Okay, and this is z_2 up, and conditional transition, z_3 up. These would be up knots. Okay, so there are my 3 pauses, right? And then I'm going to transition unconditionally back to this state. And it looks good because it looks like, wow, it hit 0, so I stay in 0 3 times, right? Okay, well, that's not true. And so I think I can draw it here. I'm gonna try to draw a timing diagram on this thing and make sure I got everything there. See how this comes out. Here's my clock. Okay, that should be enough states. And I'll put a count out there. I'm going to change that count every rising clock edge. And I'll start it at something arbitrarily, like we'll say 14. Okay, I need to see the RCO, and I need to see a state. Okay, that should be good. So here's 14 goes to 15, and that's when the RCO turns on. And then the next stage is going to be to 0. Okay, so the important part here is that I get the state right. Okay, so I know it's already getting kind of messy here. Okay, looking at state. Heck, I know the RCO turns off. I know it stays off. I'll just leave it off. Okay. Okay, so what it's going to be here is it's going to be in SCNT. That's this state right here. It's going to be SCNT, which is it's also that state, but the RCO turns on in this state, so it's going to transition to Z1. Unconditional transfer to Z2. Unconditional transfer to Z3. Okay, so there it is. And in this state, it's going to unconditionally transfer to SCount. Getting really messy there. And check it out. The problem here is that SCount, SCNT. The issue here, if you look at this thing, I've got 14, 15, 0, 0, 0, 0. There's 4 zeros there. That's absolutely not what I want. So what I need to do is fix this. And what I have here is one too many states. So the moral of this story is you got to be careful of these things. They're not exactly as typically as intuitive as you seem. Like I need 3 zeros, right? I have three states with the up turned off. It's obviously too many. So let's go ahead and fix this. Wow, a nice eraser there. Get rid of that too. And once I do this, once I just get rid of a state here, what it's going to do is transfer not to Z3, but it's going to transfer, I can erase this too. I shouldn't erase that, but this is going to go to SCNT. It's going to be SCNT for all these states. And what's going to happen here is it is going to go at this point, it enters SCNT at 0, but up is turned on in there, and it's going to start counting at that state. 2, 3, 4. Anyway, the moral of the story is be careful of these things, and I don't know what else to say about this problem. I hope that makes sense. Onwards, folks.